record, share the screen, select the screen, share. What? Why doesn't it my? Wow. What the hell is this? Do you hear me, guys? Hello? Oh yeah, I'm sorry. My computer was shut down because there's no power. I'm like converting it. Okay, so how do you hear me? Boom, boom, speaker, this. Okay, let's start. Thank you, Peter. Okay, let's watch in the lab here. If you look at the lab here, I attached a couple of links for each sorting method, right? So there's a very small section here. This is my explanation. If you find it hard to understand, you can watch a video. I suggest you to watch a video, of course. It's very like easy to understand, except the quick shot. Quick shot is hard. Okay, let's watch the first video, bubble shot.
Here's what we'll do. We're going to compare consecutive items. With each iteration. A sorted partition will form at the end of the array. It's pretty simple, so I'll be quiet and let you watch.
So we compare pair by pair, right? Consecutive pair. If it's smaller, we move it, we swap position of the pairs. So at the end of the first loop, we got the biggest one.
9 is now in the correct spot. Let's continue. You get the picture. I'll see you at the end of the algorithm.
Quite simple, right?
We're done. Our array is sorted. Here's the pseudocode for bubble sort.
Just that's it. Right. This is the outer loop. You start from the beginning to the end of the array. And then for each element inside that loop, we loop again so that we can compare pair by pair. So bubble sort is very it's very similar to the selection sort. So it's, you may be confused between the two. So here is the
You can
first.
guess from the nested for loop, the worst case time complexity is big O of n squared, where n is the size of the array. If you have questions, please ask them below.
Again,
big O of n squared.
Again, look at this. I from 1 to n. And then j from 0 to n minus 1. So basically, we want to start from I, 0 until array length, less than array length. And then inside it, we will start with j from 0 to same thing. So do you have any question like why do we start from n from 1 here instead of 0? Why do we have to start from 1 instead of 0? Yeah, could be. Yeah, that's it. So we don't need to compare the first element, right? We only want to compare the first with the second. So we don't need to look the first one. Okay, let's do it in JavaScript. So I'm gonna leave this one here, open JavaScript to what is this? And go back to the classroom, select bubble shot. So I unsubmit it. Okay. So let's start with a very simple array for 7, 2, 3, and 5. Okay. So let's try to do it manually to see how it works. Yeah. On the first iteration, we look at number 4. We compare 4 with 7. If 4 is greater than 7, we swap it. If not, we just skip it to the next. How do we say, it's the next iteration. So the first time 4 and 7, we still keep it. So it's gonna be 4, 7, 2, 3, and 5. Second time it runs, we check 7 and 2. Okay, so it's gonna be 4, 2, 7, 3, 5. Okay, next. Oh, it's not here. It's not this. It's gonna be 3, 7. I have to do it step by step. Next, it's gonna be 4, 2, 3. What? 2, 4. Yeah, I want to keep on doing this here first. We have to swap. So there's a loop inside a loop. That's why it's very hard to understand at first. So at the end of the first loop, it's gonna be like this. 7 is gonna be at the end. Okay. And then when we start the next loop, it's gonna be 4, 2, 3, 5, and 7 again. Nothing changed because 5 is the second greatest number. So this is the outer loop. It's gonna be now. It's gonna be 3, 2, 3, 4, 5, and 7. So this is the end of every outer loop. But inside the inner loop, there will be like 7. We move here and then here and then here. So that's the inner loop. Okay, so let's code it. I'm gonna define a function called Photoshop. You have to use the same name here. So I have a check here, a function to check the results, if it's shorted or not. So you have to use the same name for the function, bubble short. And we have an array. Okay, we have 2 loops for I equal to, we don't start with the first element, right? We don't, well, like there's no thing to compare. And then array of r length less than 1 plus plus. Inside that outer loop, we have another inner loop for j equal, now we start from 0, then r dot length less than, wait, what the hell is it? Yeah, what the hell is that? Sorry. Delete it. And I less than array dot length. So in the pseudocode, they actually have -1 here. Let's see what happens if we don't have it. Okay. J plus plus. Here is J, not I, sorry. J and then J plus plus. If we don't have it there, J will get out of index if we have J plus 1. So in here, I would say if array J index is greater than array J plus 1 index, right? We will swap. We swap it using the swap function. I forgot. Let's go back and copy our own code. It's okay to, oh, it's not here. Sorry guys, the learning portal is not updated. Bina, can you? Yeah, thank you. Actually, I have another function, swap function here, but it's not updated, so you don't see it. Just let's take 1 minute to define it. Function swap array I and j. And let's use the shorthand array r I, comma r j equal r j r I, right? So we swap the element inside the array. Okay, if the previous number is greater than the next number, we swap position. Swap array comma j plus 1. Oh, not again. Okay, here we go. So now here's the problem, guys. If I don't have length -1, j will get out of the index here. You will see an error called index out of range or out of index. So that's why we need -1. Okay, so that we can keep j is lesser than the array length. Right, so finally we return array. And I hope it works. Don't know yet until you run it. Console log bubble shock array. Okay, let's run it. Okay, it does shop it. The shop. Very simple. Okay, do you have any question about the logic or even the code? I know it's fast, but this.
How long is it supposed to take to run the code?
If it takes too long, you can stop it. It should be very quick. Yeah, you stop the code and run again. See what happened. So something wrong there. Something wrong in the code. Oh shit! I don't see the chat. Hello, Huy and Minh. It's very clear, right? So the difference between okay, when we go into the selection chart, I would say the big difference between those two. So right here, if you have question, please ask. Let's try with different numbers, right? I'm gonna try with 1, 4, 9, and then 0 here. Run again. Short it. Very fast. Question? No. All right. So here the idea of this shock, bubble shocks, is we have two loops, the inner loop and the outer loop. For the outer loop, we like basically every shock needs the outer loop, right? Every sorting method needs the outer loop. But it depends on the sorting algorithm, we need the inner or not. So here, the idea here is we need it in order to check, to compare each pair. For example, we compare 4 and 7, and then it's going to be, so I will do the inner loop here. I will explain the inner loop here. These 4 lines here, the outer results, right? So here's the inner result. First, we check 4 and 7. Okay, 4 is lesser than 7, so we keep it. So the first time it's run, it's going to be like this. Oh my God, it's too long. Let's remove this. Okay, and 1 as well. Right, so it's going to be 4, 7, 2, 3, 5, and then it's going to be 4. So this is inner loop. 7, 2, 7, 3, and 5 now. Next, 4, 2, 3. Oh yeah. No, not really. Still this. So the next outer loop, we will change the 2 and 4, right? So here we still checking the number 7 here. Keep checking it. 7 and then 5. So 4, 2, 3, 5, and then 7. Okay. Oh shit, something wrong. Yeah. So okay, now there's no need for this. Then we finished the first outer loop, right? So next, another inner loop. So we have a bunch of inner loops here. Result again. So it's gonna be 4, 7, maybe. What should it be? We check the next number, which is 2. 2 and 4. Really? I'm confused now. So what's the difference? Oh shit. This is 2 and 4. Sorry. So it's going to be like this. We check 4 and 2. So we have 2 and we have 4. And then we have 3. We have 5. We have 7. Next. We still have 2. We check 4 and 3. So we have 3 here and 4 and 5 and 7. Next. 2, 3, 4, 5, and 7. It's done. So finish the second one, which is and that's finished. So magically, we have to run three loops. We run a bunch of loops, right? So it's going to be 1 multiply. So it's going to be O n square. Because we have a loop inside a loop. The outer loop, we have to iterate through all 5 elements. The inner loop, we also have to iterate through all 5 elements for each element. So it's going to be n square. Okay. Since we are just rearranging the number, why do we range the range of number decrease? Oh, this is just what I want to log out the difference between the results. Okay, the difference between the results. So we can do a console log here. Console log array here. You should see the results. I say inner loop. At the end, shit, something wrong. Run again. Okay, as you can see, for every inner loop, you see the result after you swap. Okay, so it's gonna be like this, or maybe this. I'm wrong, maybe, yeah, here. And then swap. First, you move the 2 and the 7, then you move 7 and 3, and then 7 and 5. Done. The next is this. Okay. And then lastly, you will have this. And this is the result, the sorted array. You only see the log after you swap. Here, you can even see the log, even you don't swap it. But here you only see the result, the change in the array after you swap. So that's different. That's why you see a little bit different from what I logged here. Right.
When I remove the -1, it still work.
But be careful, because we have what? We have J plus 1 here. I don't know why it works for you, because if you remove -1, it's going to be get out of index, right? J plus 1 is going to become array.length, and there's no such element. So be careful.
We like to like RG -1.
RG.
If RG -1 is lesser than RG.
Lesser -1.
Yeah. You reverse that.
So problems, we start from J, we start from 0. If -1, again, our index. Okay. So there are a couple of different ways to write the for loop, but This, I think, this is the most straightforward way. Okay. Did I answer Min question? We have to -1 for the second loop. Yeah. Okay.
Can you scroll on to the swap function? Because for some reason it's not right.
Okay, Min, if you draw -1, J is gonna get out. You will see some error here. Okay, cool. Next function, I'm going to submit it. I hope I pass the test. Yeah, submit. Okay, back to the classroom. Move on to the next shorting method. So learn short. So let's finish this and we'll take a like 10-minute break so that you can actually code. I'm gonna unsubmit it. Yes. Oh, same thing. Delete them. So I'm gonna keep the swap here. And here's an explanation for the. Oh, let's take a look at the video first. Sorry. Selection shop. You can read all of this, or you can just watch the video. Let's start with selection shop.
Today we're going to learn selection sort. Let's say we're given the following array and we want it sorted in increasing order. How will we do this? During each iteration, we'll select the smallest item from the unsorted partition of our array and move it to the sorted partition. We'll keep track of the current minimum and current item with red and blue arrows. Let's get started. We always set the current minimum to the first number in the unsorted partition, in this case 2. We progress the length of the array looking for a smaller number.
We find the smallest number.
We find 1 at the end of the array and set it as our current minimum. We swap 1 and 2. We now have 1 item in our sorted partition. Moving on, we set 8 as our current minimum and scan the remainder of the array for a smaller number, updating the current minimum as we progress. At the end, we find 2 and swap it with 8. We're ready for the next iteration.
So
This time, 3 moves into our sorted partition.
So it's kind of like an improved version of the bubble shop, right? You only swap at the end of the iteration, the inner loop, or maybe at the.
Let's watch the rest of the algorithm play out.
You do less swapping. Okay.
Pretty simple. With each iteration, you select the smallest item that hasn't yet been sorted. Here's the pseudocode for selection sort.
Right. So we still have outer loop and the inner loop. Okay. Don't worry about this line here. It means just generate a temporary number, right? And then we check if the target, the current target, is the smallest number. We mark it as the I-min here, and then we swap it at the end of the loop. Why do we have this? I don't know. We can skip this. So at the end of the final inner loop, we can swap, meaning every iteration of the outer loop we swap. Okay. Here is checking if there's any change in the value here. If there's a change, we swap. If there's no change, we can skip it to save the computing power. It's very smart. Yeah. Right. Let's watch. Continue watching.
As you can tell from the code
Same.
and the nested for loop, selection sort has the time complexity of lego of n squared, where n is the size of the array. Thank you for watching.
That's it.
Please subscribe and comment suggestions for future videos.
It's just 2 minutes. All right. Can anyone do it? All right. The swap function here is the same, right? So I'm gonna explain it line by line here. So I'm gonna only explain the iteration, the outer loop. First, we find the smallest number. It could be the smallest or the greatest. If the greatest, we put it at the back, at the end here. If smallest, we put it at the front. So depend on what you want to do. So I'm gonna go with the smallest number. So I'm gonna find the first loop. 2 is smallest. So I'm gonna swap 2 with 4, right? So it's gonna be 2, 7, 4, 3, and 5. Next. So it's going to be 2, 3, 7, no, 4, 7, and 5. If you can do this, you understand the short. Next, 2, 3. Oh no. What the hell is this? 3 and 4, 7, 5 again, right? Is it?
4, 5, 7.
No, 4, 5, and 7. That's it. We reached the end of the short. All right, let's try it with actual code. Function selection short array. Same thing. We do a for loop. So 0. I is less than array dot length. It's so dark. Okay. Increment it. So here we need to find the current minimum index. Let's define it. Let current minimum index, okay, equal to what? This is important. I. Okay. So why? Why do we need this? Because after we finish a loop, right? We just keep it still. 2 is the smallest number, we know for sure. So the next iteration of the outer loop, we don't care about 2 anymore, right? We don't touch it. So we need to increment I. I is going to be 0 and then 1. So the current minimum will be 3, for example. Okay. Right. So that's why current minimum index is going to be I. And here we continue the inner loop for j equal to, here is also important, I, right? Last one, yes. Okay, j as well, array dot length. Okay, comma, j plus plus. Right, question here is, do we have to j plus 1, length minus 1? Maybe. So let's do it. If we have if else here, we check if j, array j is greater than, no, we're not checking j. Yeah. If it's greater than, it's less than the current minimum. If it's less than the current minimum, less than current array, I'm gonna copy and paste. So this is index, right, guys? Index, not the value. It's the index. So we need to check the value of that index. If we find a smaller number, right? If we find a smaller number, we assign the current minimum index to J, right? And then keep doing that until we reach the end of the loop, which is this curly braces. Yay. Comma, so down here we swap array. So here's the important point. What do we want to swap?
And then
Yeah, it's outside the inner loop array. Is it?
no, I mean 17, right? Should be less than array name. Otherwise, the last.
Yeah, correct. So we don't need -1 there. We don't compare it with any next number, right? We only compare it with the rest of the array. So we don't need -1. So here's the most important thing here. We need to swap. We swap I and we swap the current minimum index. It's okay, it still work here. It still work, I guess. You can do console log. You need to return it. Return array. Okay. So let's console log it. Selection short array run. Please no error. Yeah, it still work, but it's not so efficient. If you want to like prevent it, like for here, we swap every time we finish an iteration, right? So there's some time that you don't even need to swap because it's the same index. So there's another way. If the current minimum index is not equal to I, you change, you swap. If it's equal to I, you don't need to swap. Okay. There you go. I will run again. You will see the same results. Okay. Questions?
I don't understand anything.
Sorry. Okay, do you get the idea of the outer loop and the inner loop yet? Like, it's clear, right?
The concept, sure.
Yeah, the concept is clear, but when you actually code, it's very confusing.
Yeah.
Same thing here. Okay, you run the outer loop. It's very normal. Nothing special about the outer loop. Okay. So here's like you generate a temporary minimum index. The temporary minimum numbers that have this index. Yeah, the current minimum smallest one. The current smallest one. But we don't care about the value. We care about the index only. So this is the index. Be careful with the index here, right? So for we run another inner loop. The syntax is very similar, but we have I+1 here because we don't want to compare. We don't want J to start from beginning. We want J to start from the current cursor. You can call it cursor, or you can call it the current element of the outer loop. So the first time it runs, I will be 0, J will be 1, right? We compare 4 and 7, right? The next time, the second loop, I will be 1 and J will be 2. So we ignore the first index completely. So that's why we have I+1 here. The rest is the same. So now inside the inner loop, we check if, for example, if 4 is lesser than 7, it's okay. If 7 is less than 2, we change the index of the minimum number to 2. We keep doing that until we reach the end of the array. And then we swap. Okay. The swap here has to be outside the inner loop, outside of the inner loop. Outside.
It's not supposed to be outside the inner loop.
Yeah, it has to be outside of the inner loop. The whole inner loop here just to find the current minimum index.
underneath the 6 to find what?
The current minimum index here on line 16. Okay. Huy and Minh, are you clear?
Can you explain why we do the bar J equal I plus 1?
Okay. We want to compare with the next number only. We don't care about the here, and we don't want to compare with itself as well, right? If j equal to I, then we're comparing the two numbers, the same numbers. So, yeah, so we only want to compare with the next number. And actually, if you have j equal I, it still works. Nothing wrong with that. But yeah, it's meaningless, so we don't need that. Okay, that's the whole shopping. Take 10-minute break. It looks like, what the hell is it? 10-minute break. If you have questions, please ask during that time. Okay.
I still understand, but
it's very hard to call, right?
Yeah, I'm not looking at all.
Yes. So there's a big difference between the pseudocode and the actual code. Okay, I'm gonna stop the video recording here, Minh and Huy. I'm gonna make the multiple short videos.